Hello, I'm Justin Smith, and this is how to narrow down your material selection with NX Performance Predictor. I'm a designer that is looking to make a more informed decision as I make updates to this battery machine. I'll start with this part of the foil cutting unit. Something important to note before using Performance Predictor is to ensure that all analysis bodies are fully loaded, otherwise you'll not be able to select them. I can do this by expanding to the component I have selected in the Assembly Navigator, right-clicking, and selecting Open Component Fully. I can also verify that it is fully loaded by checking the current load state. Now that we've completed that crucial step, let's focus on just this component by right-clicking and selecting Show Only. Let's go to the Performance Predictor application and start a new analysis. This one will have the material set to steel, so I'll name it accordingly. You can adjust the resolution automatically using this slider or by defining a specific voxel size. Since this is a rough proof of concept, we can keep it fairly coarse without changing the voxel size. You'll want to start by defining your analysis body and select each component you want to include. The material will default to steel. The connections will automatically generate, but if I wanted to edit or create additional connections, I would just select the two touching faces and it would add the connection. You'll see as I click through these, each individual face is highlighted at the connection. These connections represent the weld for each of these components in the assembly. As with any application, typically commands are ordered from left to right as you use the application. I will start with the analysis constraints, which will be these fixed holes for the machine screws that attach this component to the rest of the foil cutting unit. Next, we will want to apply our loads. We have a wide range of loads to choose from. I'll start with a remote force. I just need to select a point, target face, vector, and specify the force. Then I will add the additional forces for the foil guides on the cutting tool. Just like a remote force, I need to select the faces, vector, and determine the force. You can also change the force distribution across the selected faces. We'll keep it even over the face area. The results are already processing as I do this, and some key information is shown. This displacement, stress, and safety factor are all acceptable for this use case. The heat map here shows the displacement across the part, with red being maximum displacement and blue being minimum. Let's take a look at these if we were to use aluminum. I can just create a clone of this setup and rename it to fit our analysis. I will need to change the material of each component to 6061 aluminum, which is in the library materials, so I'll select that. I need to apply this material to the other components in the subassembly, so I'll just do that now. Since that is complete and all their constraints and loads are already applied, we can double check the results for steel. Now I can compare these to the aluminum results and make a more informed design decision without needing to export or simplify the assembly parts within NX. In this demonstration, we selected a subassembly in the context of a larger assembly for analysis. We then automatically generated connections for the individual components and set our constraints and loads for analysis. We were then able to compare our feasibility of using steel or aluminum for our components. Thank you for your time and attention.